I'll just, point. We're good? Awesome. Perfect, thank you. So thank you everyone for having me. I'd like to start my talk by talking a little bit about myself and my path that took me to do my PhD. So I'm originally from Portugal. I'm from a small town of about 2,000 people, very close to the center of Portugal, to the capital of Lisbon. I've always lived close to the ocean. And ever since I was like 5 or 6, I was obsessed with dolphins. There were dolphins everywhere in my room, and all I wanted to do was study dolphins and work with dolphins. So I did an undergrad in Lisbon in environmental biology with a focus in marine biology, and I got kind of thrown into a master's in marine ecology. And I studied the social structure of bottlenose dolphins that were resident close by to where I was living. So social structure is kind of like who hangs out with whom and how that changes with time and the way that different individuals hang out together. And for social animals, social structure can go from super fluid with like bottlenose dolphins. They hang out in groups. The groups break apart and reform within a couple of hours, to super like complex and hierarchical, like with the orcas. So you have the matrilions, you have the grandmothers, the mothers, the kids, and they all tend to stay together throughout all of their lives. So most social structures fall in between those extremes. Then when I was studying when I was studying the bottlenose dolphins, I got to work a little bit with baby dolphins. There were some baby dolphins popping up in the population, so I got to figure out how to identify them, how to figure out who the mothers were, and that came nice and handy for my next step. So I finished my master's, and there was a recession going on. I couldn't find a job. I couldn't pretty much get any paid job. And I was like, what do I do now? Like, well, I've always wanted to go abroad and study abroad. So this is the perfect opportunity for me to go do a PhD someplace else. So I started a PhD in biology in Canada, in Nova Scotia. And it took me a little bit to get my funding and everything, and I started in 2009. And I studied the same topic as I did for my master's, but with a different species, with pilot whales. So we already knew a little bit about the social structure of pilot whales. We knew that they lived in social units. So social units are a little bit similar to the orcapods. They're little groups of whales that tend to stay together throughout like several years. At this point, we knew that they would stick together for like 7 or 8 years. I wanted to find out how long. Were they staying together for their lifetime? I wanted to figure out what they were comprised of. Did we have males and females? Were there families? Were they matrilines? All of that cool stuff. So I got integrated in a long-term study that started in 1998, and in 2009, I started collecting more data for it. And kind of as an afterthought, my supervisor mentioned, well, people have been doing this, collecting this data for a while. They keep telling me that the babies don't stick with the same adults all the time. Maybe you should look into that. Like, that's part of social structure. Do you want to take a look at that with your PhD? I'm like, oh, yeah, that sounds really, really cool. I definitely want to look into that. So one of the chapters in my thesis, and it ended up being my favorite one and the one that I love talking about, is on allocare. So allocare means that the calf or the baby is not just hanging out with their parents, it's hanging out with other adults in the population. And you might be thinking, that's babysitting, right? That's what we call babysitting. Yes and no. Babysitting in scientific terms is a specific set of allocare. And it means that who is taking care of the calf is changing the way they're behaving to care for the calf. So my favorite example isn't even from marine mammals, it's meerkats. Meerkats, like when they have their babies, they do daycares. So when all the adults go out to find food, they stick all their babies in a burrow with a babysitter. Everyone goes out to eat, and the babysitter sticks behind and takes care of the babies. That's an example of babysitting, because if there were no babies, that babysitter would be hanging out with all of the adults getting some more food. So I knew I wouldn't be able to study that with the pilot whales in depth, because the way that things are organized and how I collected the data, they wouldn't allow me to see that. So I just studied allocare. Are the calves hanging out with more than their parents? So does it happen? If so, who is taking care of the calves that are not the parents? In order to do that, I had to ID not just all of the adults, which we were doing beforehand. I had to learn how to identify pilot whale babies, which was an endeavor all on its own. Okay, so next slide. I'm going to take you to beautiful Pleasant Bay and teach you how I actually collected the data and what I learned about pilot whales. So this is Nova Scotia. You can see like Halifax over there at the bottom. This is where my university was, and every summer, me and a field assistant for 3 years went to Cape Breton. And our study actually started in 1998, all over here on the tippy top of Cape Breton, because there were a lot of pilot whales over there during the summer. A couple of years later, the pilot whales migrated a little bit down, and that is where we were when I was collecting my data in Pleasant Bay. And actually, a couple of years after I finished my PhD, the pilot whales moved south again with the food, and now you can see them more closer to Shetty Camp in the south. So this is beautiful Pleasant Bay, where I got to spend 3 summers out of my life. It's one of my favorite places in the world. It's a teeny tiny town that has about 150 people in the summer, about 50 in the winter, I believe. Most people leave during the summer because the mountains get snowed over and they just get stuck most of the time. But there's a lot of tourism. It's in the middle of a national park, so there's a lot of tourists going on, and there's a lot of whale watching happening in this area. So we were working with a whale watching company, and it was a really cool deal. We got to go on for free on all of their trips during 2 months to get data. They got to tell everyone that they had researchers on board, and we got to talk to everyone that was coming on the trip. So we got to tell them what we were doing, what data we were collecting, what were we studying specifically, and we got to answer everyone's questions to the best of our knowledge about the whales. And I actually really, really loved doing that. So most of the trips, we were down here with everyone else. When we were with the whales, we were up here on the middle deck, so we could run around, one of us with the big camera taking photos, the other one with the clipboard, writing down all of the things that we were seeing. So from Pleasant Bay, we could go anywhere from 12 miles north or south up to 6 miles offshore. And each one of our trips lasted anywhere between 1.5 hours and 2 hours. It kind of depended on where the whales were, if they were close by, if they were further away, if we found them right away, or if it took us like half an hour to find them. We did up to 5 trips a day, every day during July and August, weather permitting. So it was a long field season, and we all really loved it, and we were exhausted by the end of it. There was 1 year where we had the most amazing weather. We had 2 days off during the summer. That was it. So I did this during 3 years specifically for the allocare study, although the study had been going on in general for social structure for a very, very long time. So when we were finding the whales, we were trying to figure out where the groups were. We were taking photos of all the adults that were there, and we were trying to figure out who the calves were. So if you've ever seen a pilot whale or a bigger toothed whale, you usually see like the blowhole, the dorsal fin, and then it goes down, and they're super smooth, right? They move very smoothly in the water. Calves do not do smooth. They're still learning how to move and how to orient themselves in the water. So they pop up face first, so you get to see like and slap on the water. That's basically how you see a pilot whale baby. They're super easy to spot, which is really, really good. So we could usually have a good idea of how many baby whales there were in a group. Unless if it was a really big group of like 50 or 100 whales, that was a little bit harder. But a group of 20 or 30 pilot whales, we could figure out who the calves were and where they were, so we could take pictures of them. Okay. So we can actually tell the relative age of the calves just by looking at them. So here we have a newborn whale. It's between birth and 6 months. And the 2 things that we know they are newborns is because they have the dorsal fin still bent over. That's because it bends over to go through the birth canal. And they have these marks on their body. So these are called fetal folds, and they're very prominent in newborn babies. And they are from when the whale was like bent up, when it was in the womb. It was bent up like this. So these are the markings for it being bent up. Then we have fetal fold babies. You can still see the fetal folds. They're not as marked. They look more like lines painted on. and the dorsal fin is upright. So these whales are between 6 months and a year. And the color is slightly different. They're born lighter, more brown sometimes than the adults, and they start getting darker as they age. And then we have gray calves. So gray calves are between 1 and 3 years old. They're mini adults. They are the same proportions as an adult. They look like an adult in mini version, basically. So at around the age of 3, they get weaned, and they can stick around with their mothers for another year or 2. But they're not considered calves anymore after they are 3 years old. So identifying calves is hard. That's what I have to tell you from the first thing from this study. So we identify whales, adults, by their dorsal fin. So you can see the little nicks and notches right over here on the dorsal fin. That's how we identify the adults. These little nicks and notches don't regrow. So if they get one, they stick with it their whole lives. Fingerprints. They're very similar to our fingerprints. And we use that to identify all of the adults. So they can be big, they can be small, but a lot of the population, a decent amount of the population has them. Baby whales are born with very smooth dorsal fins. So these nicks and notches, they happen with life, basically. It can be from bites of other whales, it can be from predators, it can be from interacting with boats, with fishing gear, interacting with anything, basically. So when we have a young calf, it's really not going to have any of these markings, which makes it very interesting to try to identify them. So I used everything else that I could to identify them. They didn't have markings? Okay, we'll use scratches. We'll use patches. We will use coloring patterns. So most of these, the thing is that they only stick around for 2 to 6, maybe 8 months. They don't stay with the whale during their lifetime, except these marks over here. This baby is called Patch, and we saw Patch during all of the 3 years that I was studying this population, and I love it because I could see what he was doing throughout the 3 years. That was the only one, basically. All of the other calves, I could identify them in 1 year, and then I'd have to reset and start again for the next year, which means that looking at certain things was a little bit harder than others. Okay. The second problem with identifying calves was gray calves. So if you have newborns or fetal folds, it's so obvious that you're looking at a baby, right? You have the fetal fold marks, or you have the bent over dorsal fin. So if you just have a photo of the dorsal fin and a little bit below it, you're like, yeah, that's a baby, for sure. But if I show you this picture without any other context, can you tell me if this is an adult or if this is a baby? I don't know. I don't have a sense of scale just by looking at the picture. The only difference between a gray calf and an adult in terms of a photo like this is size. So we had to work around this when we had our data set to be able to see what photos we had from adults and which photos we had from different calves. So we used marker photos. So whenever I took a photo of a calf, of a baby, I took a photo of water right after it. Whenever I took a photo of the escort, the adult that was with the baby, I took a photo of the horizon. And usually what would happen was like I took a photo of the adult, I took a good photo of the baby, and then I took a photo of the markers in the same order. So as I was going through my data set, I'd be like, oh, we have these 2 photos. One's the adult, second one's the calf. Another thing that we were doing that was new for this study that wasn't specifically just for the allocare was genetic sampling. So we were collecting skin samples because one of the things that I was looking at social structure was trying to figure out if we had males and females in units and how related they were. But this informed a little bit of who the allocarers were for my study, who was taking care of the calves. So how did we collect skin samples from the whales? So we had a really, really strict protocol to make sure we weren't hurting the whales, that we weren't harassing them, doing anything like that. So we used a crossbow with a special dart, and we were aiming, I say we, I didn't shoot any crossbows. I was partnered with someone that had been doing this for several years and was really, really good at it, thankfully. So we were shooting at the area right below the dorsal fin because that's the area that the whales have less nerves. So they're less likely to feel that anything is happening. This has a stop collar that's foam, and it means that it rebounds on impact. So the dart hits the whale, gets a skin sample that's about this big, rebounds, floats on the water, and because it's super colorful, once the whale moves on, we can slowly approach and collect it from the water. And this is what it looked like on the boat. We were doing this before whale watching hours, so anywhere from like 5:30 a.m. until 9 a.m. And on very good days, if we finished early, we would be doing this also from like 6 p.m. until 8:30 p.m., like sunlight hours. And in between, we were going out on the regular boat with the whale watching and getting all of the other data. This made for really long days, but we usually did this like 1 week at a time. So I was with the camera taking photos, so I knew exactly who we were getting a sample from, so I could identify the individual. And we were only getting samples from individuals that were super obvious, that we knew for sure they had enough markings that we could identify them. We had a person with the crossbow, and we had someone that was doing video. So they were doing video right before, during, and after the sampling, so we could make sure that we knew what the whales were doing at all of those points and see if they were changing their behavior or not. And they weren't. Like, all the data that we had published, everything points that what we were doing, it wasn't really having an impact on them, which was what we were expecting, but it's good to have reassurance that we were doing the right thing. The only time that we really saw a whale change their behavior and do slap with their tail was when we missed it and we hit the water close to it. So it was probably the sound. That was something that they weren't expecting. They didn't know what was going on, and that made them uncomfortable. That was the only case. So after 3 field seasons and 356 identified calves, what did I learn? So the first question, is allocare happening? So first of all, I had to narrow down my data. I had a lot of data, a lot of babies and escorts and companions that were identified. I narrowed it down to calves that were seen 3 times or more. If we see them once, we weren't really sure if we would have enough time with them to see if they were spending time with more than one adult. More likely if we had 2 encounters, but if we had 3, we were like, okay, if this is happening, super likely that we are getting enough data for this. I found out that newborns are impossible to ID. We're using dorsal fins. Their dorsal fin is still bent over. Managed to identify 1 newborn during 3 years, and that's because it had a big scratch right below the dorsal fin. That was it. So we can't really know for sure if allocare happens with newborns or not because we just can't identify them. But for the other calves, most of them had more than 2 companions. So allocare is happening. They're not just hanging out with their mothers, they're hanging out with other adults. And the numbers are like, for 2009 and 2010, it's around 70% of the calves were spending time with more than 2 companions. It's around 60% for 2011. So allocare happens. It's actually really common in this population, which is really cool. And it happens both with the younger calves, with the fetal folds, and with the older calves, with the gray calves. It's just we don't know about newborns. What do we know about the companions? So we know that there are many companions to each one of the calves. They are not, surprisingly, in the same social unit as the mothers. So in the beginning, I mentioned that pilot whales live in these groups that stay together for long periods of time. So in my study, I figured out it's pretty much a lifetime that they stick together. The allocarers, like the ones that are hanging out with the baby whales, they're not from the same group that lives together throughout all of their lives. When you see a group of whales pilot whales out in the ocean, it's comprised of several different units. They stay together for like a couple of weeks and then they break apart, get together with other social groups, and that's how that happens. So it's whales that are in the same group, but not in the same social unit that are taking care of the calves. And we had the amazing chance that we had 6 companions that we knew the sex of. 5 of them were males. So this is really, really uncommon for marine mammals, like for whales in general. It's usually the females that help care for the calves. It's not usually the males, no. This doesn't mean that it's just males that are taking care of the calves, but it means that it does happen. It's both sexes that are doing it, which is really cool. The one thing that we didn't found that we were kind of expecting to see was reciprocity. Not within the same year, not between years. So there was no, you take care of my kid, I take care of yours. Within the same year, okay, fair enough. We have enough data to look at that. Between different years, it is a little bit harder to look at because we couldn't see the calves, the same calves year to year. So there might be a gap there. It might also be the case that the allocarers are taking care of the calves. Like, it's not, you take care of my calf, I take care of yours. Is I take care of your calf when I don't have a calf of my own. So the calves can stay with their mothers up to like 5 years. So it might be after that, after they leave, that they're like, oh yeah, I don't have a calf, I go help with the others. And we only looked at this for 3 years, so we didn't have enough data to look at if that was happening or not. Okay. Why don't we know more? The biggest thing is that calf ID is really, really hard. So again, like allocare across different years, it's really hard to figure out without being able to know that it's the same baby throughout different years. It's hard to look at things in more detail. Also, identifiable adults in the population are relatively low. It's about 30% of all adults that we can identify in the population. Only 30% of them have enough markings for us to identify, which for social structure, it's fine. It gives us enough data. But in this case, it means that we had a bunch of cases where we couldn't tell who the mothers were. It was like we saw baby A with adult 1 a couple of times, adult 2 another couple of times, and then like 20 times with at least one adult we couldn't identify. So yeah, allocare is happening, but we can't tell who the mother is in that case. And we have so many whales and not enough re-sightings. So when I finished the study, we had identified about 3,000 whales in this population. If only 30% of them are identifiable, it means there's at least 9,000 of them in this population. That means we are not seeing the same calves and the same adults all the time. We might see calf A with their companions 2 or 3 times during a summer. It means that when we get a good photo of the calf, we might not get a good photo of the adult that it was with, or vice versa. Sometimes we did, sometimes we didn't. So it is what it is in this case. It does really make it really, really hard to look at reciprocity. So what does this all mean? Well, it kind of depends if allocare is costly or not. So a cost of allocaring can be that if you're escorting a calf, you might be spending less time foraging, looking for food. Kind of like the meerkats are like a really extreme example, but it might be something like that. It might be that because you have a calf, you're more susceptible to predators. Like they look at the calf as like easy target, and you're right there with it. So it might be you might be putting yourself at risk for being with a calf. When something is costly like this, it means that there's an evolutionary mechanism that's behind it. In this case, it would be reciprocal altruism. So you're doing something that's bad for you, but it's good for someone else. So it's bad for you that are escorting, it's good for the calf. And the idea is if it's reciprocal, that eventually someone's going to do something good for you that is bad for them. For young females, it might be a way to learn how to care for calves. They can't reproduce yet, so it's kind of like learning how to take care of a baby if they're escorting. For males, it might be just showing off. And there is a theory that's called social prestige that I absolutely love. And the idea behind it, it's basically a male being like, yo, look at me. I am so fit. I am the best of the males that I can even hang out with a little calf and not spend as much time eating, or predators look more at me. See, I'm that fit. I don't care. You should be mating with me. You want my genes for your babies. So that might be the case. That's happening. But it seems less likely that allocare has a cost for pilot whales. So if allocare doesn't have a cost, there's no evolutionary mechanism behind it. It means it just happens. And individuals can act the same whether they're caring for a calf or if they're on their own. And it's kind of this that we're seeing out on the water. In reality, there isn't anything that doesn't have costs. Everything that you do has a cost. But the cost in this case can be really, really low. And that explains why males allocare. If a calf approaches them, they don't have to do anything different, like, cool, calf is with me. But it might be really, really important for the calf to be hanging out with all of these different adults. They're probably learning different social norms, especially if they're like hanging out with adults that they don't get to see all the time, that they don't get to live with all the time with their social units. They might be learning feeding strategies. They might be learning how do they make decisions, who decides where the group goes. They're learning a bunch of different social norms, which is really, really cool. So in conclusion, it really does take a village to raise a pilot whale. Allocare is super common. It happens with both males and females. And they're not from the same social unit as the mothers, which means that units don't really work just on their own. It takes a whole population to take care of a baby pilot whale. And we didn't find reciprocity when we were looking at this study, but it is very possibly happening. We just didn't have the tools to look at it. And honestly, I would love for someone to actually take a look at that specifically with this population. That would be super cool. And it seems that it's really likely that allocare for the pilot whales doesn't really cost that much for the adults, but it's an invaluable experience for the babies. They're learning so much when they're hanging out with all of the different adults. And that's it. Have a bunch of thank yous to people that helped me when I was collecting data, when I was in the lab, and to my funders. And thank you all for listening.
Thank you so much. That was wonderful. I don't know about you all, but this day of talks has just been really invigorating and inspiring, and hope you're all excited for tomorrow already. But let's get into our Q&A here. We have our microphones. Raise your hands if you have questions.
On the idea of reciprocity as well as reciprocal altruism, does that mean that like potentially this is a genetic marker for empathy in another species?
That is a really, really good question. I would love for someone to actually look at that. Yeah, that is a really cool idea. There might be, yeah. So this species is super understudied. There's a lot that we don't know about them. Up until like 4 or 5 years ago, they, like in the IUCN Red List, they were listed as data deficient because no one wanted to study them, basically. So it's really hard to get funding for a species that is everywhere and it's not endangered. So it's a good question.
Hi there. I'm wondering, as far as the different social units, what the geographical range of the population that you were studying was, and considering different feeding strategies and different information that might have been swapped around within that population.
Yeah. So this population of pilot whales summers in the Gulf of St. Lawrence, so in that whole inner area of Nova Scotia. We kind of don't know what they do over the winter. We kind of speculate that maybe they go down to the Carolinas, they might go offshore to the Atlantic. No one has studied that. In terms of feeding strategies, it's completely possible that different units have different feeding strategies or different preferences in terms of food. So these guys can eat anywhere from, well, squid is their favorite food, but they eat a bunch of other different smaller fish. So how much they are eating of each, we don't know if there's preferences within social units. We do know that social units have preferences for each other, though. So for instance, like social unit A, E, and G are seen together a lot of the time, but they never hang out with P, S, or K, stuff like that. So it's really interesting when you start looking at details like that. Yeah. One of the things that I wanted to study when I started was looking at markers for food and what they were eating, but I didn't get the funding to do that. So, yeah.
Okay, so are pilot whales like dolphins where somebody can actually get in and dive with them? Or do you have to go from a distance?
We usually go from a distance. With this population, we've seen people kayaking with them relatively close by, and they didn't seem bothered by it. But I haven't really heard of anyone diving with pilot whales. They're usually pretty uninterested in us. They're more interested in the boat if the boat approaches them. They play around on the bow of the boat a lot, so you see them like kind of like with the dolphins, like playing around at the front of the boat. But yeah, usually the couple of times I've seen people try to like go swim with them, they just ignore them. Not interested.
When you earlier in the presentation, you said that the whales would migrate up and down the coast. Did you notice like the different groups hanging out with each other? Like group A and B would hang out here, but not up here at all?
So we didn't really look at the geographic location of them. We know that like different social units tend to hang out with different social units. They have preferences for sure and aversions, but we didn't take into account geographic location though. That's not something that we looked at, but it's a good point. I don't know if we would have had enough data for that because since we were working with a whale watching company, we went for the whales that they first saw. Just because we were with a group, it didn't mean that there were not 5 other groups around us. We just didn't get to them because we had a limited time, and it makes sense. If you're with a whale watching company, they go for the closest group.
You towards the end you mentioned these whales not being studied a lot because they were I can't remember what you said, they were understudied.
Data deficient for the most part, yeah.
Was there a particular reason why they're understudied, or was it because there was just so few of them?
It's the other way around, actually. There seems to be a bunch of them. There seems to be like a lot of them. So usually with marine mammals, you get more funding when you know that the species is endangered because you need to learn how to preserve it. If you're studying a species that is everywhere, there's a bunch of them, there's less funding for them. It's unfortunately how it works. They are now considered until like, I think it was 2018 or 2019, least concern. So we know that they're doing well, at least. There's a bunch of them in the North Atlantic and a bunch of them in the South Atlantic.
So kind of building off of that last question, what are you specifically hoping is going to come of this research, or what do you want to see further in a study?
That's such a good question. Honestly, like the person that started doing research with these guys after me is now looking at something really cool. They're using drones to look at decision making in pilot whales. So figuring out who decides when the group changes directions and how all of that works. So they're looking at like leadership basically in pilot whales, which I love. It's not something that I would have even attempted. The math is not for me, that's for sure. Quite honestly, I would love to see someone just do like what we call a focal study, is when we're with the same group of whales throughout a full day. So you just like take a boat out and you spend the whole day with them, and you can take a look at what is happening during that day. So you could get a really good snapshot of like allocaring, who the calves are with, and how much that changes within the day. I'd love for someone to look at like the details of that.
Hi, I wasn't sure if you're studying short-finned or long-finned pilot whales.
Good question. Long fins. So long fins are anti-tropical, so they happen in the North Atlantic and in the South Atlantic. Short fins are tropical.
Awesome.
And then there's a little area where they intermingle, and there's hybrids.
Well, I'm not aware. I don't think long-finned pilot whales go through menopause, do they? Because if they do, would you think that a menopausal female is more likely to take care of other children?
So we don't. So yeah, short-finned pilot whales, they definitely go through menopause. That is proven. There is a paper from the 60s, from when we used to fish these guys in Newfoundland, that gives us, it's like, it might be happening. it's like, I kind of believe in my deep self that yes, but there's not enough scientific evidence for us to be able to say if it's happening or not. But yeah, if it is happening, I'm pretty sure that, yeah, we have grandmas taking care of the calves. And that was one of the things that I wanted to look at with social structure, was like the whole, like, do we have the grandmothers, the mothers, the kids, and pilot whales? We don't. It's not how they do it, but it's cool.
Hi. You said in the 3 years that you did this research, you found over 300, or identified over 3,000 individuals.
Yep.
Are you certain, and how can you be certain that they were 3,000 different individuals? Did you use a computer program that you uploaded the photo ID photos into?
So identifying pilot whales is a fun thing. So we know for sure that the markings that they have on the dorsal fins don't grow back. So that's step number one, to be able to identify them. And we do use a program. The program sucks, but we do use one. So programs that are used to identify different individuals are very geared towards bottlenose dolphins. The shape of the dorsal fin of a bottlenose dolphin is completely different from a shape of a pilot whale, which means that the software that we're running was built in 1996. It works in MS-DOS, and we need to use like floppy disks to move it to a new computer whenever we get a new computer. It's the one that works the best. So we still do a fair bit of cleaning up the data set by hand and making sure that all of the photos that we enter, we pre-select them together. So we go by hand. They're like, oh, these don't have enough markings, throw away. These will look and we'll like do batches. So these 30 photos are of the same whale. These 40 photos are of the same whale. And then we run the best photo and only the best photo through our database. Yeah, it is a time-consuming job that a poor co-op student did for me for several years. Yes. Yeah.
I was wondering why they're called pilot whales.
So the lore says that they used to pilot fishermen to good feeding areas, basically. If they followed the pilot whales, they would find good schools of fish. Yeah. I honestly believe that because they are good fishers. So, yeah.
Do we have any other questions? I have a question. Oh, Maddie has a question too.
Hello? I have a question.
Yes.
So for that drone study, is there any like thought of trying to match it with acoustics, like recording acoustics at the same time and see what's going on? Like what are they chatting about when they're looking at who's moving where?
I don't think so. So when
Are they pretty chatty?
Oh yeah. Yeah, they're loud. They're very, very loud. They have there's a study on vocalizations on them that is like super interesting because they add embellishments to their sounds. So they copy each other, but then they add like little flares to the end and the beginning of their whistles. But I think from what I know of the drone study, it's being done from shore. So they don't have anyone else in the water at this point recording sound. Yeah.
Oh, there's one in the back there.
Yes, ma'am. Yeah. With your study, have you seen reciprocal studies in other species of whales based on your research, or has there been further look into the social structure?
Not with my research, but I know that sperm whales are reciprocal, definitely. So they tend to, and most of my lab studied sperm whales. So yeah, that kind of. So what happens is that sperm whales, they dive really deep to get their food, and the calves can't dive that deep when they do that. So they all hang out at the surface, and then there's a babysitter that hangs out with them, and they swap who the babysitter is throughout different days.
How can you identify the sex of a whale?
It's just by genetics. So once we have the skin sample, there's markers that we can use using PCR for the X and for the Y gene. Yeah, that's as simple as that when the PCR goes well. Not always, that doesn't always go well, but yes, when it goes well, it's a simple genetic test.
In your study, on the ID that you got, the DNA, how many whales out of total whales that you observed did you get any ID information from?
In terms of the genetic study of like getting the skin samples, we got 80 something during 3 years. And we were supposed to only do 2 field seasons, and we're supposed to get about like 20 to 30 per field season, and 2011 failed spectacularly. We had really rough weather. We just the driver of the boat just wasn't as comfortable as we were expecting. We got 3 samples. And I cried myself to sleep at the end of that field season, thinking that I was never going to finish my PhD. And my supervisor got enough money to do an extra field season in 2012. So I went up to Pleasant Bay for an extra 2 weeks during the summer. And we got like 30-something samples in 2 weeks. Yeah, about 80-something individuals out of the whole population. That's what we got. And that was still enough to figure out a couple of things for social structure.
Okay. Thank you so much. I would like to have everyone join me in a round of applause for Joana and for all of today's speakers.